I'm Luke.
And I'm Drew, and today we will be talking about how aquatic plants can help reverse ocean acidification.
Over the past 200 years, since the Industrial Revolution occurred, in the mid-1800s, more carbon dioxide has been produced and released into the atmosphere at alarming rates.
But more carbon dioxide in the air equals more carbon dioxide in the water.
Right, so CO2 molecules in the air bump into H2O molecules in the water, and they create a large molecule called carbonic acid.
Carbonic acid has the ability to dissolve carbonate, which is one of the main ingredients to shell-building aquatic creatures that will die without these shells.
So our real-world example is that marine ecologists planted baby oysters around Tarts Bay in Oregon to see how they would do in the more acidic ocean. What they found was that the oysters that were near eelgrass and other aquatic plants were the only oysters that thrived.
They're thriving because the acidity of the ocean around the plants was lower. The reason that the aquatic plants are lowering the acidity of the ocean around them is because they perform photosynthesis, which takes out CO2 from the ocean and making there to be less potential for carbonic acid to form and creating a little space in the ocean of more pH and thriving plants and animals.
The cost of replanting aquatic plants, such as eelgrass beds, takes a lot of time, effort, and money, but over 9,000 acres of seagrass have already been replanted in Chesapeake Bay, Virginia. It is also absolutely crucial that we try to keep the already alive aquatic plants living.
Overall, there is still hope for us to reverse the effects of ocean acidification, but we need to act now instead of waiting another decade.
So here's our model we drew up on our proposed method of how to fix ocean acidification.
So as you can see, this model is split up into 3 specific sections and is sort of similar to the model we all drew up in this class recently. Starting with section 1, it represents a factory during the Industrial Revolution, which poses as the burning of fossil fuels leading to an increase in CO2 molecules caused by this human activity. In section 2, these molecules travel through the atmosphere, colliding with each other and eventually entering oceans and large bodies of water, forming carbonic acid. Moving on to section 3. Section 3 represents our proposed method of how there is less potential of carbonic acid to be formed when aquatic plants that photosynthesize are present. This leads to species and aquatic life in the ocean thriving.
I'm Drew.
And I'm Luke.
It's been real.
Thanks for watching. Real rural. Once. All right. And then, yeah. So our real.